So what I'm going to talk about today is like nothing very rudimentary stage. Like I will take you through a life cycle of how to manage life cycle of a machine learning project, and I would just do kind of a hello world example of so that you can connect the dots. So the problem, that's why I called it like end-to-end ML. So the problem we are trying to solve here is so 85% of the data science projects never sees the daylight of production. Like if you like most of the time, the AI scientists of machine learning model builders or data scientists, they build their models, and that's just there. They have good, accurate model, but that's not productionized, and that's the reason it's not. They don't deliver any real life business value. Very few has. So that's the problem we are trying to solve, so that we can, as soon as we have a model developed, we can productionalize it and see in the production setting and generate business value out of model. So is there, the question we are trying to address here is like, is there any way we can put more models in the production, like so faster deployment of models in the production setting? So that's the problem we are addressing. So now the question we will ask next is like, which are the projects which has been productionalized most? So if we go to the realm of software, we'll see that software has evolved from like your local computer to production setting faster than anything else. So software deliver a real-time business value better than ML, most of the machine learning projects. So software projects. So the next question we should ask, like, so the answer to this question is like software projects, right? So how is it done? Like, how do they productionalize something so intangible? We cannot touch it. It's an user experience. And how do they do the productionalization of software and deliver the business value? That's the question. So now any modern software deployment process is done through Docker, Kubernetes, and continuous improvement and continuous delivery, these three things. So anything which is nowadays, everything is moving towards microservice paradigm as opposed to monolithic paradigm. And instead of deploying a web service, a huge, humongous web service, we are breaking it up into smaller services, which is good at doing one thing and one thing only, containerizing it, deploying it through Kubernetes cluster. And those things are auto scale, and then we are putting it in the CI/CD pipeline or continuous integration, like Travis CI or GitLab CI. So that's the idea. So next question we should ask is like, can we use the same concept from software development lifecycle to our ML project to make this machine learning projects or machine learning models in production setting, make it available in production settings so that we can deliver business value faster from machine learning projects? Turns out that yes. So there are some differences between a software and machine learning projects. So machine learning project learns from data. So we have to control, if we figure out some way to control the data nuances and model specific nuances, that is possible. So we can apply the same concept derived from software development lifecycle into machine learning project. So that's why Kubeflow was invented. So steps to do machine learning project is there are some steps which should be followed for any project. So these steps are like, get the data, clean and prepare, manipulate the data, then train the model, then test the data, and then improve. So these are the kind of a 5-step prototypical steps which every machine learning model follows. So that's where then the question comes in, like, how would we use, like, so these are the steps we follow for machine learning project, and we know how software is developed and productionalized. So these are the two things which we know. Then how would we map this concept, software development lifecycle concept, to the concept of machine learning? So let me start my demo. So I prepared this two repository, REPA MLOps and REPA Web, to walk you through step by step how softwares are developed or webs are developed, like websites, through a hello world example, like a very 101 people who don't know anything about software, about Kubeflow, to walk them through step by step. So this REPA web, uh, so we can clone this. So I already did that. Can some I am and REPA. So if you guys want to walk through the thing, so those are uh, those are public repositories, so you can clone it. So so in my desktop, I have these two folders. So I will walk you through basically this instruction set, which will also be found in the repository. Uh, to walk you through first the concepts of software development guidelines, and then walk you through the machine learning guidelines. So let's, if you uh, if you guys can you see my screen still, like the desktop, all these repositories?
Yes,
Yes.
yes, we can.
Okay. So let's open this and kind of analyze what we are doing, and slowly understand what we are supposed to uh, walk through. So step one, so if you look at this instruction set, I will put it in here too on the side. So step one is like create the GitHub repository. So you will create a GitHub repository, and then I'll clone it in the local machine, so that you have version control in place. So that's the step one. Then you make an application. So that's where I'm starting. So this is like simple Node.js application, which is like a hello world. Everyone knows what it is doing probably. Like if you are not a web developer, maybe you would not know, but it's basically a Node.js application. It's getting some library called HTTP and host name this and port this. So if I run this application locally, if I open my terminal, let me know if you can see the terminal too. So if I go into that folder, oh, sorry. So I can just run that hello.js and I will see what it is doing, okay? So this is basically serving this string, hello world, to this port. This has nothing to do with machine learning, by the way. So this is how web is developed. So I will walk you through how website is developed. Then I will walk you through the analogous process, which can be done in machine learning. So if we do node hello.js, so now if we go to this this address, we'll see that that's printing hello world. So that's the first step, right? Step one. The next step is, so you will make a sorry. So let's turn it off. Let's stop the web server probably. So next step is we will containerize the application hello world and run it from the container. So you can think of the container as a Docker container as an isolated environment which runs your application. So it basically solves the problem that it's called like it works in my computer, on my computer syndrome. You know, like many of the software we develop, it works in your local machine, but if you give it to some other person, they cannot run it because of these requirements and other stuffs which are not installed. But if you containerize it, it will give you an isolated environment to run your application. So the way to containerize it is very simple. So this one is a simple application. That's why containerization is also simple. So first line is saying from node 14. So imagine this as like a computer you just bought without any software installed. So first thing you do is to install an OS. So you can imagine this as base image from node. So this is like your OS, and we are copying all the files here to your containers, and then exposing that port and then running this node hello.js. So now if we build the container image here, so the commands to, I think I lost that instruction. Where is it? Can you guys see the instruction on? Sorry.
Yeah, we can see everything.
Oh, okay. So this is the instruction set I prepared. So that's what I was looking for. So now you will build this image with this command. Don't forget this dot. So docker build. So now if we go to the repository and build this, so this built the image. So now we will run it, the same application from the container inside the container. So if you go to the instruction again, you will see that the command for that is like run docker run. So if you just run that, you will see that. So again, you do the same thing. You go to the this port and you will see, but this is different from what we did earlier because we were running that application in local machine. Now we are running it from the container. So the next step is, so I can just stop it. I can just terminate it probably. Yeah, if you do docker, yes. Stop. I'm just terminating the image. Okay. So the next step, next logical step is to deploy it in Kubernetes cluster. Step 3. So you have a Hello World application. You made a containerized, then an isolated environment. Then you deploy it in a scalable orchestration platform called Kubernetes. Kubernetes, you can imagine as the, it's like orchestrating all the images. Like if you have hundreds of Docker images, so this platform basically auto scales, auto hills all those Kubernetes, all these Docker containers or images, and runs automatically depending on your need. And then so it manages the images, basically the container images. So the way to do it is first you need to have a Docker repository. So you have an image, so you need a way to store it. So for me, I made this repository here. So you can, it's free of cost. So you can make your own repository and push your image. So, so now, so as I already did this Docker login, I don't have to do it. Docker push this. So this image is already there. So the next step would be to make something like this YAML file. So the way to deploy it in Kubernetes cluster is to make a declarative statement like this, API version, and this is a deployment type. So Kubernetes has different objects. So it's a deployment type, and then we are deploying hello app. So that's the deployment name and exposing this port. And it's getting the image from my repository, Docker repository, where I stored that image. So you need to fix the permission issue and everything too. So now, if we go to the statement, so if we do this, kubectl apply. So I have to start my Kubernetes cluster. So locally, so in order to start and to have a single node Kubernetes cluster, you can do minikube start. So I'm assuming that you have minikube installed in yours. So minikube will start. It will take probably a few minutes, 1 minute or so. In the meanwhile, if you guys have any questions so far, I would be happy to answer. Okay.
It seems, yeah, it seems we don't have, at least now.
Okay, yeah.
If any question, please write to the chat channel or Q&A, and I'll translate them to Ritaban.
Sure, yeah.
Thanks.
So what we did so far is like we have an Hello World application software, and we are kind of doing SDLC, software development lifecycle, with that. So we containerized it and we are deploying it in the Kubernetes cluster. And in order to, so this is very reproducible. So I'm doing it in my local machine, but all these things should work in different clouds, AWS, GCP, or Azure, wherever you want to spin up your Kubernetes, provided you have Kubernetes cluster available, it should work there as well. So now let's do this. Let's do this. So now this YAML file which we made, type deployment. So we will apply that and put it in the Kubernetes single node Kubernetes cluster using this command, kubectl apply hello.yaml. So that deployment is ready now. It would take some time if it is a bigger application. As our application is just a hello world application, it would not take. So now if we look at the deployments, you'll see I have some Airflow pods, but this is our application which we spin up. So now we have to look at it from the Kubernetes cluster. So the command for doing that is this. So we'll expose the node port for kubectl, and then we will see that if we do this, this application will open from Kubernetes cluster, not from container, only Kubernetes cluster. So it's printing hello world, so expected behavior what we did, but this is from the Kubernetes cluster. So the steps to do it. So then again, the thing we did is we made a Kubernetes cluster, and then Kubernetes cluster, and deployed our Hello World application, containerized Hello World application through Kubernetes cluster. Now the question comes in is, can we do the same thing for our machine learning lifecycle? So I'm stopping Minikube now. So that's where the Kubeflow pipeline will come in the place. So let's go to sample. So equivalent Hello World project for machine learning is Boston housing project. So everyone starts with that, probably machine learning project. So get the housing data and predict the housing prices depending on different parameters. So if we let's do Jupyter notebook and open this this thing. So I put this. I did full disclosure. I did not develop this. I found it, but this is like very common Kaggle data set, right? So the machine learning lifecycle starts with this. So you get the data set, right, and then analyze the data and do some data munging, like what is going on, numerical variable, what to do, temporal variable, like how much time passed from the, like how old your house is, and then all these things you do. This is very prototypical discrete, what to do with discrete variable, what to do with continuous variable, what to do with numerical variable, and all these things. So I went through all these steps in different. So this is where the data scientist starts their workflow. So the life cycle of machine learning project starts here in the Jupyter notebook, and then they go through all these steps. Then they first data analysis, then they do feature engineering, they normalize some feature, then like make it standardize some feature, make the new categorical variable, transform them into something like that. So all these things are basically remove the like null values, how to treat them, like missing values and everything. So this is the work of the data scientist. So all these notebooks now, this after this is done, after the model is developed, after the model is developed, you will see. So features, then they will select the feature, and step 4 is model building. So this is very prototypical machine learning, data science life cycle. So a data scientist will sit in their Jupyter notebook and develop a model. So this is also a Hello World project, a Boston housing project, which I found in Kaggle, and but that's not the main motivation behind the talk. So we don't need to discuss this further. So the next thing is, how would we make it productionalized? So we already know how to productionalize web project. The way to productionalize is like make the application step 1, then containerize it and deploy in Kubernetes. And now we want to map those concepts in our machine learning as a machine learning problem. So if we go to the another repository, which I pasted here. So if you open the REPA mlops, that's where we will learn how to make this Boston housing project, turn it into a production workflow. So if you open the component, so the way to do it is exactly similar. So Kubeflow is basically Kubernetes machine learning pipeline running running in Kubernetes. So you probably already guessed that there is a Docker container needed. There is a Kubeflow cluster or Kubernetes cluster needed, on top of which the Kubeflow pipeline will run. So I will just spin up the pipeline if as that takes a little bit of time. So so the command for that is background. So it will take a little bit of time to spin up the pipeline, but in the meanwhile, we can discuss how this is done. So the concept of in Kubeflow, the basic fundamental concept in Kubeflow is component. So each of this machine learning stage is one component, and one component consists of like a container or container image, and then YAML file. So, and then you tie those components together as DAGs to orchestrate. So I will stop here again, and if there is any question before I start showing you what component contains.
Ritaban, what should we put into the component? Different stages or steps in our machine learning pipeline?
You can do it as granular as you want, but yes, that's the idea. You will. So I will show you what I did. So I just put this to feature engineering and training, as you can see. I did not do the data analysis part, but in the feature engineering, if you open this folder, you will see the structure of the folder. There is a source folder where I'm putting the application basically, and there is a Docker file, and there is component.yaml. Exactly similar to the web project, remember? So web project has hello-world.js, Docker file, and YAML file, hello.yaml, right? Exactly the structure as web project. So each component is basically one step, or as granular as you want. If you want to do like some, like just, so the concept of microservices, smallest is the best. So if you just want to develop a component which just takes the data, gets one feature set, and removes all the null, that can be done too.
Okay, so, thank you.
Yeah, the idea is if it fails in one small component, then you can easily debug it, because it's just probably 10 lines of code. You can easily debug that. That's the idea. So in the component.py, I put all that script, which was from Jupyter Lab, actually, Jupyter Notebook, that script basically. So this is a Python script, very common, right? It's reading the data and doing some separation and everything. So component.py is the code. That's where the code is hosted, SRC. Now, if you look at the Docker file, it's doing the same thing. So base image is Python. You're installing all the dependencies here, and then copying all this code into this repository, copying the data set. This is not a good practice though. I did it because it's very small example, that's why. But the way to do it when the data set is really huge, it's called persistent volume claim. And that can be done, or you connect your S3 bucket or something where your data is hosted through your Kubernetes cluster. But here the data set is like really small, and this is just a hello world example. That's why I copied all the data set in the container itself. But this is, you should not do this in production setting, these 2 lines. Now running the Python 3 components. And now how we will communicate this with Kubernetes cluster is exactly the same thing we did before, is this, make this YAML file. So in this YAML file, you see I already registered feature engineering to my Docker container repository. So I put the image to the registry, Docker registry or Docker hub. Now I can show, now this is one component, then another component is training. You can see. So it's the same structure, SRC. So you have Python script here, similar thing. Then Docker file here, doing the same thing, and component train.yaml. That's getting the, pulling the latest image again from the Docker hub. So you need to fix the permission and everything. So now what to do with this component, right? Next thing. So that's what I will show in the Kubeflow. Let's see if it is running. Okay, so this is the port where minikf. Then minikf is also, it's called mini Kubeflow. It's also for local experimentation. But this is also like, it can also go into any cloud. So it's spinning up, sorry. So it will take few minutes to spin up. So now the next task, which is machine learning specific, is to tie these 2 components together and make a DAG or make a pipeline. So that's what I will show, how to do it. Yeah, I will also walk you through the Kubeflow interface, web interface, and that's how custom components are built. Then you can make it as complex as you want. If you have deep learning pipeline or anything, you are doing more complex tasks, which we do all the time in our company, like make transformer model and productionalize it. So this is done through Kubeflow. So that can be done. Any types of complex models, deep learning model in GPU cluster training, everything can be done. But as this is just a preliminary tutorial, I did not put all those complexities. Does it make sense so far, or any question?
It's clear.
Yeah, it's clear enough.
Okay, thanks. Yeah, so it's spinning up. It will take probably a couple of minutes. Then I can show you how Kubeflow interface looks like, and then how to tie them together as a workflow and make DAG out of it. So the idea is exactly similar. So I think the thing I wanted to convey in this talk is the microservice architecture. So that architecture I showed when I deployed the web application, that is precisely what microservice entails. It does one job and one job very well. So each of this component in Kubeflow is basically a microservice. What is the benefit of making each component a microservice, like preprocessing a microservice? Because microservice scales, auto scales. So if you have a huge amount of data, you are throwing it to the pipeline, it will automatically scale. That microservice will scale and handle that data. So you don't necessarily need to worry about all those things, like will it scale? Will it scale? And if you have small number of data, small amount of data, it will scale down. If it is like some container is failing, Kubernetes is smart enough to detect that something is failing, and it will turn it off and turn up another component, like another container automatically. So you don't have to worry about it. So it's very robust architecture. That's why it's very suitable for production level workflow. And another thing is like it's very composable. So I will show you in a minute how it is done. So you can just move one file from local machine to cloud. It should still work. There is no way, there is no need to do anything else. Just moving from one place to another place or one cloud to another cloud would be very easy. Just moving is a matter of moving one file from one place to another place. So yeah, all those things can be done. So composable, reusable, and scalable. These are the three benefits of using Kubeflow over anything else. So getting the pods ready. Let me see if I can do something else. So far, I think, yeah, I showed you guys this, feature engineering. So each of these steps, so if you can make any n numbers of components here, like you can say that remove null, one component, but the structure, if you maintain like src, I put src, but you don't have to name it that way, but yeah, app, Docker file, and this component.yaml. That's all you need for Kubeflow to work. 44%, probably can take a little bit of water. Okay, so let's wait probably. There is no more question. I will just stop and wait for it to spin up. And the same paradigm applies to clouds. Like Google Cloud has their own AI pipeline, which is basically Kubeflow. And then AWS, you can host this in EKS cluster. Azure, you can host this Kubeflow in AKS, Azure Kubernetes Service, probably. That's what it's called. Yeah. So no matter where you are running, it will still work. So movement is easy. It's multi-cloud, reusable, composable. Okay, I wish it was a little bit faster, but no. So spinning up.
Maybe you can tell us while it's loading, what might be the main issues while implementing this into the pipeline?
The main issues we usually see is related to permissions, basically. So you have to fix all the permissions in Kubernetes. That's the main issue we see. Like if you want to move from one place to another place, and you like for example, if you move this pipeline to Google Cloud, you can spin up the cloud, Kubernetes there and Kubeflow there. But as soon as you move, you see that there are errors coming in because of the permission, because it doesn't have the right permission. So you have to fix, for example, it cannot pull the Docker image from your image hub, like the Docker hub. So those kind of things which we see. Also, there are different, like if you don't know how to do networking within Kubernetes, that might be another issue. But as soon as all those things like infrastructure is set up properly, there should not be any issues. And usually machine learning engineers or data scientists, no one handles those infrastructure issues. Those are like a different department, like infrastructure department. They will make it happen for you. So you have to go a little bit of back and forth with them to fix, like, hey, it cannot address, like it cannot access this S3 bucket. It cannot access this repository, that kind of issues. Not issues related directly to containers or your code or anything. But yeah, of course, I'm assuming that you are writing the right code, right containerization is right and everything. So does it answer your question?
Yeah, makes sense. Yeah.
Yeah. It's very
so
efficient.
it's like we need a collaboration with kind of DevOps engineers.
Yeah. So
Yeah.
exactly. Yeah, you are exactly right. So DevOps engineers and infrastructure people, if you collaborate with them, go back and forth, then it's after this is spin up and runs properly, there should not be an issue. So
Yeah,
now,
okay.
yeah.
Thanks.
Yeah. So now it is spin up. So this is the interface. This is how interface looks like. So you have home, where all your everything you have is kind of here. It's a dashboard. Then pipelines. Pipeline is like whatever has been run. So it lists all the experiments. Then our notebook server, that's where we will go to make our pipeline. So I already have this REPA notebook server, so I'm spinning it up. See, that's where the magic will happen. So you will see how easy it is to make the pipeline here. So I deliberately put this to component train.yaml and component.yaml from here, from the repository. See these two files, component.yaml and training as component train.yaml there. That's all you need to tie them together. So that's all the information Kubeflow pipeline, KFP, this library needs to tie these two together. So I will just run these cells. So first is you are loading the component from component.yaml, but this can be any path. This can be a S3 bucket. It can be your GitHub repository, provided it has access. It can address to that GitHub repository path. It will get that component from there. I just wanted to make things simple. So component train. Then this is the way to tie it. So this is a decorator where you're creating the pipeline, and then you're importing this compiler. But where is it? So where it is? So let's change this experiment name. So experiment is where you are having like bunch of pipelines. So experiment consists of bunch of runs. So you might decide first run, you might decide to change some parameters like data set, maybe you are adding some features. And second run, you are removing that feature. So an experiment will consist of all the runs you run. Or maybe in different times of the month, you want to run the pipeline. Like probably February, every like month, 15th of every month, you run the pipeline. So that can be automated through this. So let's say, let's call it REPA experiment demo and run these things. So now you will see, you will get an experiment link where you have create component run. That's where you can visualize how the component looks like. So it's it will pull the feature engineering first. So it's running. So if you look at logs, yeah, it will pull the GitHub repo, Docker image from the Docker hub and run the code and give you the output. So you have to wait for that, but it will tie these two together as a pipeline. And then you can change, so I will show you how to clone. So this ran, so you can go into this and go to the logs. I don't know why the logs are not showing. It's weird. It should be there, but okay, let's wait for this to finish probably. So you can tie them together as parallel. So you can run them parallelly to, you can tie them as sophisticated way you can want to. So one experiment and more run you have, it will be gathering those runs in under one experiment. This is really weird that it did not get any logs. Probably I made some mistake. I don't know. Probably I didn't put the logs there. But this train is running now. It's getting the component. But yeah, so that's pretty much it. So you can put a CI/CD like Travis CI or GitHub CI around it to trigger the runs too. Or I will show you another thing. So if you go to the pipeline, anything, if you click on one pipeline, for example, this is not a good one. So you can create an experiment from here. Let's say test. You create an experiment, then you can choose the pipeline which you want to run here, or upload a pipeline. What is upload a pipeline? That means, so if you go to that Jupyter Lab we spin up, you see this create component.zip, this file. So all you need to do is to download this file and put it wherever you want to spin up next. Like, let's say you want to move it to, let's download this. You will download this in local computer and move it to probably Google Cloud. You can just upload this part, create component.zip, and then create a run from here. So you can upload that pipeline and run them. It would still work. And you can do also recurring runs where you can do periodic. So you can do minimum current run. So maximum concurrent is 10, but you can specify like start date, end date, and minutes like that. So yeah, so that's pretty much I think it. Let's see if that job finished. So it's very easily movable. So you can just get that zip file and put it in GitHub, in Google Cloud or AWS or Azure from local repo. The thing is so reproducible that it can still get all those images right and create a pipeline for you and create a recurring run or whatever way you want to spin up. So that's the idea. My computer is behaving a little weird now, of course, because it's demo time. So they usually behave bad when we demo. I don't know why it is spinning. Anyhow, I think I conveyed that my message, even though I cannot see the experiments.
Yeah, it's okay, no problem. So this is a demo course.
Yeah,
everybody face it. Yes, for sure.
Every time I try to demo, something will happen. Like, oh my goodness, this is weird. Anywho, but you got the idea, right? So you bring, you make this pipeline composable and movable. All you need is this YAML file. So another thing I want to show you is like, you guys is like this GCP AI Hub, I think. So if you go to GCP's AI Hub, they have many components here. One stuff. So you ML. Okay, probably you have to log in, but they have their own custom-made components where you can just specify the input code and where the output will be stored. You don't have to make this custom components all the time, like the way we made like Docker file or component.yaml. You really don't have to do it because there are many open codes which are out there which can be used. Like you can reuse it. For example, XGBoost has its own component made in Google Cloud. So you just need to specify the input path of your data set and output where you want to put your data set. That's it. And XGBoost component will run. So the way to get those is like specify the whole name here, where the YAML file is, that YAML file of that particular person who made it, and reuse it. So that's the idea of Kubeflow. Like you can reuse as many components as you want without even bothering about containerization or anything. But the demo was for like how you make a container component from scratch. So if you want to make your own component, that is doable too. And you want to always make it in such a fashion so that you can just specify the inputs and outputs and it will still work. I think whatever I wanted to tell is I already told. So if there is any confusion, any questions, all this instruction and all this thing are in the repository. I can send an email out to Michael and he can probably put it somewhere where it is accessible.